Good afternoon, guys. Welcome back to MTVTA. I'm your guys' host, Trent Manager. Just wanted to take a second, guys, this afternoon to kind of get down and nerdy with you guys just for a second and kind of explain the back end in the sense of, what I do for work and kind of just explaining the values of these smart contracts. And it's very hard a lot of the time to, grasp the magnitude of a technology if you're not working with it or you don't see the power behind it. So real quick, I wanted to kind of go over the smart contract. Nothing too long, only 32 lines written in Solidity language. We're using Remix, Ethereum's IDE, so a nice built-in virtual environment for us to work in with little to no consequences at all. So the cool thing is just some real quick things I wanted to kind of go over into the breakdown is to, really what you're looking at for people who are not on the tech side and, understand functions and the way they're written. So the contract that we're looking at now is a hotel room booking system. So the situation for the hotel .sol Solidity, the smart contract that it's written for is a replacement for booking agents on fulfilling rooms and events such as music festivals, sports gatherings, Super Bowl, etc. I can probably tell you guys have maybe been traveling and been having a hard time, either booking Airbnbs or booking hotels or anything along those sectors, and especially when it's during busy times of events, it can definitely become a headache, and it'd be probably a lot easier if you could do something like this I'm about to show you that could possibly eliminate some of that headache. So one of the things I definitely wanted to explain real quick, actually there's a couple parts, it's a sense I can kind of break down each sector as, if we click here, we kind of have a little bit of roll up phase, and if you click, all of these sections, they kind of roll up into nice little compiled lines and little paragraph sections. So before we hop into the code, I definitely want to make sure that people are understanding what we're looking at. So exactly what we're looking at is this smart contract that's developed for the explanation that we explained. And so what some of the key things I want to lay out here is paying the owner to book a hotel room, special events in particular. Modifiers equals the run before the function. So for example, function book semicolons. Brackets closed, payable only while vacant, and we can implement these check runs in between our functions that can check price before execution. They can rerun the scan before executions as well. So basically, just making sure that the functions that are executed correctly and that the requirements are met. So for example, we can definitely kind of break that down a bit further. So ensuring the conditions are met before the functions are executed in order of the smart contract to make sense. So another example would be check price, check status. If either one of these are not met below the functions, therefore it will not execute. The best example I like to put in this way is you go to a soda machine, you swipe your credit card, and you do not fulfill step 2, which step 2 would be entering the drink selection that you would like. So that would be such as F2, E8, or S5 along those lines. So if you were to skip that second step in that drink machine purchase, it would not execute to the next step as well. So therefore, your money would be returned to your card, and the machine will go back to factory set and be wait for the next customer. So that's kind of a really good way that you could think about these smart contracts and the way that they compile and execute their task and functions in each way. So for example, for another one, just to really integrate learning into this, receive external payable only while vacant costs 2 ether. So minus we don't have the check price and check statuses implemented in between our lines to let our smart contract know that. But the way this is structured, just to not get too overexposed and over my head here, the implementations, there are shorter shortcuts that can be applied inside these functions for us not to have to spell these out. So moving forward, let me give you a nice demonstrated example, and we could definitely move from there. So coming into here, we can, first things first is definitely deploy our smart contract. So deploying, we have a nice green check which shows our contract was deployed onto the blockchain, and it's giving us some information on our transaction hash, our contract address, our input, and so on, and also our value of ether. So we did not put any Ethereum or down payment for this hotel room just yet. So another thing we can do is that now we see our owner, which is this wallet here, which has about 999 ether. Of course, this is all synthetic and not real ether at all. But another thing we can do is that we can switch our address. So let's say we are now Susie or someone different. So now we are going to paying the hotel owner, which could possibly be Marriott. And let's just act like this is the main address for Marriott. So what we can do is we can simply first, let's just do it for quick example purposes. We can click 1 and see what that does. So we enter in one value of our ether, and if we kind of go back and kind of revisit what we were talking about in the first minute, we can see that it costs 2 ether to book this hotel room. So let's see what happens when we do not meet the requirements for booking the hotel room. So, okay, cool, we got an error. So the smart contract had reread to us that this was not the correct amount. So if we read through slowly, we can see not enough ether provided, debug for, more explanation, but we don't need any because that's how our smart contract was designed to work. So we did not, Susie did not enter the correct amount of ether to book this hotel room. And that is completely fine. That is exactly how we wanted it, and we can see kind of all through everything that would happen. So in this case, the ether would be returned to Susie, and she would either have to provide more ether, or she would take her Ethereum back and find a different output, hotel or so on and so on. So where this is taking out is taking out the middleman and taking out the need for human interaction and through the booking process. So for example, how this can be definitely most useful is a last minute trip for scrambling of hotel rooms, or anywhere that is being overran, specifically with high traffic volume, and you don't have that human booking system to implement these calls. And so where we can also keep moving forward as well is we switched over our account already, and another thing that we can do now is let's do our 2 ether as well, and let's also transact with that. See how that goes. And cool, awesome, that's cool. So we got actually a green check mark, so it shows that our hotel room was securely booked for the 2 amount of ether as the minimum, as that's what it's cost to book a hotel room in this IDE scenario. So completely nice environment for us to test this. So yes, boom, that was awesome. So another thing that we can also test is just to double check that things are correct, and it's multiple functions within the smart contract. So even going back to our Grammarly explanation, and we can kind of even cover it a bit further, is that just like I covered here, if trying to book twice, require will run through functions for execution or double check for the correct amount, time, vacancy, and any other variables that are written within the smart contract. So therefore, giving it a bit more flexibility. So for example, it could be what would happen if Susie had executed her 2 Ethereum deposit, but then sooner or later, or maybe something came up, and now she has to withdraw, from that deposit as well. And that was just a given example, but you can see how things can get relatively confusing if you don't have all those functions and executions correctly available in your smart contract. And the cool thing is, most of the time you won't even get to the part of having the compiling section. So this section, even getting this far to even have these errors, because there are the smart contracts need to be written in a certain format for them to even be accepted by the blockchain to even perform their task. So we can definitely keep going as well, and kind of just show even deeper as to what the smart contract can do. So let's say we wanted to pay again. So let's say Susie's friend, say Ryan, wanted to book the same hotel, and let's say Susie didn't tell him that she booked the hotel. Maybe it wanted to be a surprise for him, and he wanted to book it. So now we can do our 2 ether as well, come down here as well, and let's hit transact. We get another error. So what does this mean now? So now that we have another error, so actually what this means, and what we displayed in our smart contract, is that currently if one room is booked within the smart contract, so Susie got to the hotel room before Ryan did, and now as Ryan tried to execute the exact same sorry guys, it tried to execute the exact same function or payment that Sally did and Susie did, and now it gives us this error message. So therefore it gives us the transaction has failed, the room is currently booked. So I just definitely wanted to hop in here and give this explanation, kind of just show the back end as to what Ethereum can do. And this is a very simple smart contract. This is only about 32 lines, nothing too intensive in the way of long carrying mass amounts of people's finances, or this is nothing too crazy. This is just, I'm just wanted to hop on here and show the power of what the Solidity language can do, what Ethereum can do, and so on and so on. And before I definitely clock off here, I wanted to kind of give the injected Web 3.0 protocol and kind of just go through that, as well as, we can not just only run this in a virtual IDE, so just a controlled environment with no consequences. If we hop over to the Robson test network, which I'm already in, which is great, this could give us a real foot in the water kind of way as to how this would work on the real wide web. So if this was how this was going to go, if this was going to go down in the real world, so we can actually just relay the exact same functions as well. So if we want to, we can just do, let's say we wanted to do it. I'm sorry, actually guys, let's go back. I'm getting ahead of myself. Let's click deploy. So what we're going to do is we're going to have the exact same kind of layout that we just did. So actually what you notice differently is that we don't have a ton of work in the IDE, so now we're moving over to MetaMask, kind of working with the real live Robson test network. So the Robson test network is just another controlled environment, but gives us the more real feel of Web 3.0, so how this would go down on in the real world of transactions. So we're getting this transaction all set up here, and once the creation of the hotel room contract is done, we can go on to the Robson Etherscan, and we can see this contract deployed on the blockchain as well, which is super great. So if we just open this up here, we see this is the Robson test network transaction only. We see the status pending, and we've seen it's only been in there for about 20 seconds. So we're waiting for the block confirmations to confirm our smart contract. Oh, there we go, and we saw our success, and awesome. So we now have our confirmation for Plus on the Robson test network, so giving us the exact same. We're running through the exact same scenarios that we did in the first test round, guys, just by the way. And also, so if we wanted to relive our exact same scenario, so let's do 2 for Sally, and let's keep that there, make sure that is correct, and keep our owner the same, which would be Hilton, and we're on the Robson test network. So if we click 2 for the transaction, so what we see here is gas estimation errored with following message, see below. So, and this is the one thing that can happen with this type of stuff as well. So so an error definitely occurred. So if you go back to our Robson test network at the top, I'm sorry guys, I actually messed up. It was already confirmed, so we didn't even need to go back and try to double book that as well. So thank you guys for the time, for coming in here, and kind of just wanting to learn more about the the development side of this technology, and really how this works and how this can be beneficial in multiple real world scenarios, not only just the hotel business, but the finance business, the healthcare business. A lot of these automated systems and other events can really provide real world benefit for a lot of individuals and so many different work sectors of life. So thank you guys for tuning in today. My name is Trent Manager. Like, subscribe, and definitely check out my channel for informational crypto related topics. We go over tons of learning, informational readings, and soon to be blockchain development as well. Awesome guys, thank you so much for your time, and I will talk to you soon. Bye bye.